Okay guys, we're into some more challenging trigonometric equations. Just want to give you a little challenge for fun here since we're all stuck at home bored, right? Nothing like a little challenging math to brighten up your day. So we're looking at number 26 on page 289 in your textbook. And this is my sixth example for section 5.4. The question says, determine solutions for tan x cos squared x minus tan x equals 0. And in the textbook it says on the interval negative 2 pi to 2 pi, but I'm going to shorten that interval a little bit just to make the question a little bit shorter, because otherwise it's super long. And just make it from negative 2 pi to 0. Okay, so I'm going to try and go through this a little bit quicker because these videos are getting really long, and I'm sure you are getting extremely bored with them. So I'm going to try and go a little faster here. So the problem is that we need to isolate a trig function, and right now that looks like it's going to be a little bit difficult to do, the form it's in, but we should spot right away that we can factor out tan x as a common factor here. That will help us quite a bit. So let's go ahead and do that, because that will allow us to then split up the equation into tan x equals 0 or cos squared x minus 1 equals 0. And then we can solve each of those separately. From tan x equals 0, we need to locate the quadrants that we're in. Actually, no, we don't need to locate the quadrants that we're in. Why not? See if you can answer that question on your own. Pause the video a minute. And the reason is because tan x being 0 would be on the unit circle, not in a quadrant. So we need to look at our unit circle. We want tan x to be 0, which means we want sine x over cos x to be 0. So we need to think about where is sine x 0, so that the numerator is 0 on the unit circle. And sine x is our second quadrant, so that would be at 0, pi, and 2 pi normally. However, our domain is negative 2 pi to 0. So instead of it being 0, pi, and 2 pi, it's going to be negative 2 pi, negative 2 pi, let me fix this so it's clear. Negative 2 pi, pi, negative pi, and 0. Okay? You can also check those on your calculator. Just put it in radian mode and do the sine of, or the tan of negative 2 pi, verify that it's 0, and verify the other ones in the same way, if you wish. And actually, yep, I just did it. I was in degree mode and I got the wrong answer and I got all confused. So make sure you don't do that. Tan of negative 2 pi in radian mode does in fact give an answer of 0, and so do the other two. Okay, from the cos squared x minus 1, we want, let me go back here to my black color. We want cos squared x then to be equal to 1. We need to square root both sides, so that means cos x would have to be equal to positive or negative 1. And again, that would be on our unit circle. So we're looking for where cosine is negative, positive or negative 1, and that would actually be first coordinate, positive or negative 1, would be the same answers as where sine is 0. In the domain negative 2 pi to 0, that's going to be also negative 2 pi, negative pi, and 0. So therefore, the overall answer is negative 2 pi, negative pi, and 0. Now, if there were different answers for this equation from this equation, then that's fine. We just put them all together. The only thing we need to do is make sure that all the answers we get are in our allowed domain, and they are, so we're good.